Now we are going to cover Lesson 3 in Unit 3, and this lesson covers multiplication with mixed numbers and improper fractions. Now, as you progress through the unit, then one of the things that is important to think about is if your student doesn't understand what an improper fraction or a mixed number is, you will want to review those skills so that they know that, for instance, in 2 and 2/3, the 2 represents 2 wholes and the 2/3 are part of the whole. Each of these are divided into thirds, so we have 3/3 and another 3/3, and then we have 2 and 2/3. When I write this on my paper, you can see that I have 3/3, another whole 3/3, and then I have 2/3. If we wanted to write this as an improper fraction, I know that my denominator stays the same. I have 1, 2, 3, 4, 5, 6, 7, 8, 8/3, or that can be written as 2 and 2/3. When I see a 3 over 3, I know that I have all three of the three pieces. So you could even box it in with the number 1 to show we have 1, 2, and then 2/3. So going through these tutorials in the OLS is very, very important and very helpful, but you can also review things in LearnZillion and other resources that we have to make sure that your child is proficient with fractions and understanding how to convert numbers back and forth from improper fractions to mixed numbers. Most of the time, we are going to want students to work with an improper fraction when computing, especially when multiplying, but throughout this lesson in Unit 3, we are mostly going to use the area model to go through this lesson. And again, these tutorials are a great representation of exactly what it means to have an improper fraction and a mixed number. As you continue to go through the lesson, don't forget that the lesson guide also gives you great resources and tutorials and tips to how to help your child be successful with this unit. Fractions can be really tricky. There's also centimeter grid paper and other resources in the resource section. So check those out within the activity book, which is for the students, and the lesson guide, which is for the parents. There's fraction circles that are also very critical to showing wholes and parts of a whole. Now this is where it gets a little tricky for many, many students. This is the area model of multiplying mixed numbers by mixed numbers. You can see it says a small rug measures 2 3/4 meters by 1 1/3 meters. How many square meters of the hallway will the rug cover? So let's say that here's our first model and it's whole numbers. We have 3 by 2. Well, I know that my rug is not quite that large. It's not quite 3 and it's not quite 2. So we are going to go through these steps and divide it up just like we did with the other models when we multiplied fractions by fractions. So here we have 2 wholes and then we have 3/4. So 1, 2, we had to divide into fourths. So we have 1, 2, 3 that we're actually going to use. So we have 2 wholes and 3/4. But then we need to multiply by 1 1/3. So if we go up and down this way, we have 1, and then we have it divided into thirds. Now if I think about how these overlap, so I have 2/3 of 1 1/3, and you can shade this in and draw this model on your own paper or draw different hash marks different ways so they can see where the marks overlap. You can see that only this portion is shaded in by both. Then this is where it also gets tricky because we haven't quite, the next unit talks about adding and subtracting fractions with unlike denominators, and you can see that all of these have different denominators. We have thirds and twelfths and fourths. What I would recommend is that you divide each of the sections equally so that then you could count up the twelfths. So this would, turn into 4/12, and this would be 4/12. This would be 12/12 or 1 whole. This would be 12/12 or 1 whole. If we drew lines this way, we would have 3/12 in each of these sections. So definitely use scratch paper and encourage your child to make common denominators, even though that is coming. They do go through those steps, so if your child is ready for that, that is fine. But I feel like drawing it out is going to be a lot more beneficial than understanding this abstract concept. This is a little bit of an enrichment type activity. Students are required to be able to multiply mixed numbers by mixed numbers and to understand the model, but they will not be required at this point in the year to make all of those common denominators. Here again, we have one that has a 16th, the rest are fourths, and then we have wholes. Well, we could encourage our students to turn all of these into 16ths. I know that 16 over 4, or I mean 4 over 16 is still going to be 4, so I could divide this out, so I'd have 1/4, and then I could have 16 over 16 here, so we could count up all the 16ths and figure that out. But it is a little complicated to do it that way, and the numbers get rather large. But after you finish the next unit, I think you'll begin to see that it's much easier to find the common denominators by multiplying by a fraction equivalent to 1 and working it out that way. What we're going to do is also head over to the student activity book, and you will see that they do use a lot of grid paper to show 2/3 times 1 and 3/5. Well, just like we did before in the previous unit, you could draw circles to show everything in this one. We have the whole thing filled up. We have the whole, and then we could have 3 of the 5. So draw circles, 1, 2, 3 of the 5. And then we would want 2/3. And when we have 2/3, we would go this way because our thirds are divided here. We have 1, 2, 3, and only x in 2 of the 3. So wherever the circles and x's overlap would be the final answer. And it says simplify the product and change to a mixed number. So we don't want to keep numbers in improper form where the numerator is larger than the denominator, so we want to convert that. And I will show you a little bit as well how we can do that. For instance, if we have 1 and 3/5, when we were growing up, we probably learned a strategy that we just multiply 1 times 5 and then add 3 more. If a student understands that, that's great. But what's also a great thing to do is show them that 1 is the same thing as 5 over 5, because we have 1 whole, and so I have 5/5 plus 3/5 equals 8/5. So I have 8/5, or I could say 5, 6, 7, 8 to get 8/5. We multiplied and then added, kind of like a little triangle. Now, if we had something such as 2 and 3/5, we would need to have 5/5 or 1 plus another 5/5 or another 1, because there's 2 plus 3/5. And you would see we have 5 plus 5 plus 3 is 13, and we keep the denominator the same, so we have 13/5, which is improper. It's improper because the numerator is larger than the denominator. This number is the same as that number. They are equivalent. So encouraging your student to understand what that means and how to go back and forth and convert them in a variety of different ways is really, really important. And definitely use that lesson guide as you teach this to help it make sense to you as well. I know that when in the past, models weren't used as much for multiplying fractions, but the problem is that we followed a list of procedures, but we never really understood what that meant. And we definitely want students to understand what it means to multiply fractions. So right here it says Antonio uses 1 3/4 feet of yarn to make each friendship bracelet. How many feet of yarn will Antonio use to make 3 bracelets? So we could say here's 1 bracelet, here's 2, here's 3. So he has a whole and 3/4, 3 times a whole and 3/4, a whole and 3/4. Then we need to combine to see if we can make additional wholes out of these parts of a whole. Because if all three of these are filled up, I only need one more. Well, I could take one from here, then I could take some from here to make additional wholes. And so using models, and you could even cut these apart and practice moving them around to see how many there are in all. So as you work through this lesson, you will it's not about really following an algorithm and procedures. That's going to come in unit or lesson D. And what I will show you is how the checkpoint encourages students to model. You do have the answer guide, which does show, like, see, we have all of these have an X because we have one whole, and then 5 of the 6 are X'd. Then we're going to go across. How many are we going to circle? We have 4/5 circled, or 4 of the 5 rows. You will see that as we go through, what you'll notice is when you see the answer 1 7/15, you can encourage your student, and this is why it's really good to maybe have the grid paper and markers to move around, because some of these can go down here to fill in this empty row, so it would show one whole complete. So some of these circles can move down here, and then you will see that what's left over after you move those could be reduced or simplified to 7/15. So as you go through and model mixed numbers by mixed numbers, and this is a strategy that not all kids will relate to, but it is something we want students to be exposed to in case this makes more sense to them than following a standard algorithm. They could possibly see a model and be able to have to interpret that model. So right here it says solve the problem using fraction circles, explain your thinking, simplify the product, and change to a mixed number. So we definitely, like I said, don't want an improper fraction to be the answer. So we have 2 2/3 4 times. So as you go through, circle 2 wholes and 2/3, or color in 2 wholes and 2/3, and do it 4 times, and then add up using repeat addition or multiplication what that would be. Here it says write the multiplication problem and product that the diagram represents. So it looks like we have 1 whole and 2/5, and we have it 3 times, and then you can come up with the answer or product of that. This one is a little more complicated, and definitely feel free to help your student with this because, like I said, adding up the different parts will be a little bit challenging. This is almost 3 and this is almost 2, so we have a 3 by 2 array or area model that they've been exposed to since 3rd grade, but we need to divide that up into fourths. So we show 2 wholes and 3/4 and 1 whole and 1/4, and you can continue dividing those up until there are equal parts. So I hope this helps you as you go through lesson C, and when we get to lesson D we will follow more of the traditional standard algorithm.